At 3:12 in the morning, a reactor room has a different kind of silence. Not empty, not sleeping, just waiting. The walls were supposed to be dead. Concrete, steel, cable, ash. Then someone noticed the black growth spreading where people could not stay. Chernobyl did not become quiet after the fire. It became watched. By guards. By instruments. By scientists in sealed suits. Inside Reactor 4, the ordinary rules felt thin. Paint lifted. Metal sweated. Dust held its breath on every horizontal surface. In 1997, researcher Nelly Zdanova entered the abandoned reactor building and documented black fungi across ceilings, walls, and cable conduits in highly radioactive areas. She found it where life should have been discouraged, not just surviving, established. Dark colonies on surfaces people avoided with meters and maps. The BBC later described those fungi as melanized organisms, darkened by pigment related to the broad family of melanin found throughout biology. Melanin is familiar in skin, hair, spores, shells. Here it looked less like color and more like armor that had learned to listen. Zdanova's work suggested fungal hyphae appeared attracted to ionizing radiation, a response researchers call radiotropism. Radiotropism is a careful word. It does not mean the mold walked. It means growth bent toward something dangerous and invisible. That is the part that stays with you, not motion. Direction. A slow leaning into the thing that should have killed it. Most living things treat radiation as damage. It breaks chemistry. It tears through cells. It leaves errors where repair cannot keep up. Ionizing radiation carries far more energy than visible light, making any claim of biological use both tempting and difficult to prove. Photosynthesis turns sunlight into chemical work. The Chernobyl fungi raised a quieter question. Could darkness use a harsher light? A 2007 PLOS-1 study found ionizing radiation changed melanin's electronic properties and enhanced growth in melanized fungi under limited nutrients. Not proof of eating radiation. Not yet. But enough to make the lab feel colder after the lights went out. The word radiosynthesis started appearing around the idea, like photosynthesis, but with radiation. A neat word for an untidy suspicion. Pause. That the mechanism matters. A story can grow faster than evidence. Science has to keep its hands on the railing. Consider the unsettling part carefully. The fungi may not be feeding on radiation. They may simply endure it better than their neighbors. BBC Future notes radiosynthesis remains a theory until scientists identify the exact mechanism connecting melanin changes to useful metabolism. That uncertainty is not a weakness. It is the door left open. Behind it, the mold keeps doing what mold does. It spreads. It waits. It turns dead surfaces into soft territory, one thread at a time, without asking what the room used to be. The species Cladosporium sphaerospermum became central to later studies because it is melanized, hardy, and capable of growing in harsh environments. Its name sounds clinical. The organism itself is ordinary enough to hide in damp buildings, soil, dust, and forgotten corners. That is the unease. The reactor did not create a monster. It revealed an old survival trick in a forbidden room. Researchers reported that radiation enhanced growth most clearly when nutrients were scarce, suggesting any advantage may depend on stress and scarcity. Scarcity changes behavior. In a stripped room, every resource becomes louder. Heat, moisture, trace chemicals, maybe even radiation. Picture the reactor after midnight. No footsteps, no voices, just instruments ticking in another room and black colonies thickening on the ceiling. The PLOS-1 team found radiation-altered melanin in ways that made it more capable of electron transfer in laboratory measurements. Electron transfer sounds dry until you imagine it as appetite, not hunger with teeth. Hunger is chemistry reaching for voltage in the dark. Whisper. If melanin is a shield, perhaps it is also a hand, blocking the blow, then taking something from it. Dadachova and colleagues proposed that melanin might help convert radiation energy into a form cells can use, but the pathway remains unsettled. One approach is to hold both thoughts together. The fungus resists radiation. It may also gain something from radiation. Those are not identical. That difference matters because it separates the survivor from the farmer. One endures the storm. The other plants itself in lightning. Experiments have not shown the same radiation growth effect in every melanized fungus, which keeps the larger claim under active debate. Still, the idea traveled. From a ruined reactor room to cleaner rooms, sealed boxes, spacecraft manifests, and questions no one expected, mold to answer. Space has its own invisible weather. Beyond Earth's magnetic cover, radiation passes through walls, bodies, electronics, and sleep. From late 2018 into early 2019, sphaerospermum was cultivated aboard the International Space Station for growth and shielding measurements. The experiment was modest. That makes it more unsettling. Not a grand habitat, just a patch of life growing above a sensor. The ISS study reported sphaerospermum grew faster in orbit than its ground control, though the experiment was small and needs follow-up. Up there, the mold had no basement, no reactor, no rainwater and concrete cracks. It had confinement. It had radiation. It grew. Researchers also detected reduced radiation beneath the fungal biomass, compared with a no-growth control, pointing toward possible shielding behavior. Research suggests that shielding could come from melanin, water, density, or all of them together. The living part is promising, not settled. There is something strange about a shield that grows. Metal must be launched. Water must be carried. Fungal tissue only needs a beginning. NASA's myco-architecture work explores fungal mycelia as potential building material for future habitats on the Moon and Mars. The idea is practical before it is eerie. Send spores. Add waste. Add waste. Add water. Let structure knit itself where shipping weight is unforgiving. Breath. But imagine sleeping inside a wall that is alive, not awake like you. Alive in the patient way roots are alive. NASA emphasizes myco-architecture remains early-stage research, not a finished blueprint for off-world homes. Early stage is where the imagination gets in, not ahead of the science exactly. Just standing too close to the glass. The same family of survival that stained Chernobyl's walls may someday be asked to line a room on another world. The ISS fungus study proposed that growing shielding in place could reduce mass launched from Earth, a major concern for deep space missions. That is the practical horror of it. The thing we fear in damp corners might become the thing we pack for the dark. If you live with mold at home, consider normal safety. Reduce moisture, use proper cleanup, and consult a professional for large contamination. Chernobyl's black fungi were not presented as household mold hazards. They were studied because they endured extreme radioactive environments. Do not try to visit contaminated sites. If you are curious, consider official sources, published studies, and museums built for safe public access. The reactor is not a haunted house. It is worse in a quieter way. It is a place where invisible damage keeps time. Chronic radiation in the exclusion zone has made the area a living laboratory for studying how organisms respond over time. Plants returned. Animals crossed roads. Moss covered roofs. Life did not ask whether the map said the place was finished. And in the reactor, on ceilings and conduits, the black colonies kept the more private record. If this kind of slow science horror keeps you company at night, a quiet like or subscription helps the show find the next listener. Softly. There is no need to make it chase us. Its patience is enough. Researchers have framed radiotropism as directional growth toward radiation, not movement by an animal-like organism. The title of this story lies a little. The mold did not walk. It extended itself, which may be worse. One careful way to read the evidence is this. Survival is established. Attraction is reported. Energy harvesting remains under investigation. BBC Future quotes experts describing the promise of the fungus while stressing that stronger mechanistic proof is still needed. That is enough for a door to remain open between reactor and orbit, between contamination and shelter, between ruin and design. NASA's fungal habitat research includes ideas for growing structures from mycelia, but not specifically turning Chernobyl mold into finished houses. The future version is cleaner, controlled, fed on purpose, watched by sensors. Still, the old image comes with it. A wall in Chernobyl, a chamber in orbit, a possible shelter on Mars. The same dark logic, translated room by room. The ISS findings were promising but preliminary, with researchers noting the need for thicker samples and larger experiments before mission use. Consider skepticism part of the atmosphere. It does not drain the wonder, it keeps the wonder from collapsing under its own weight. Because if the fungus is only a shield, that is strange. If it is a battery, that is stranger. Either way, it found a way to remain where we built a place too hostile for ourselves. Long after the alarms, after the maps, after the doors were sealed, the black growth stayed on the wall, turned toward the invisible.